And start, Dr. Okuyama. Thank you. My name is Junichi Okuyama. I am from the division of Graduate School of Informatics of Kyoto University. I would like to discuss the biologging technology, which is useful for the observation of sea turtles and their life. This is in the first picture. Sea turtles are the subject, and they are living in the coastal region with shallow water. Sea turtles can be observed with scuba diving and also biologging. So they can be observed in those two primary methods. It is now breathing. This is actually the sea turtle whose species is called the hawksbill turtles. And the Becco shell is collected from them, hawksbill turtle. When we are talking about sea water animals, there are certain unique features, and they are subjected to buoyancy, which is not the case for other living creatures on the ground. By taking advantage of buoyancy, they live underwater. So please look at flipper strokes. But it has stopped, and without using the flippers at all, it is floating on the surface of water. Positive buoyancy is given to them, so by using any energy, they can actually go up to the surface and they can breathe. And when they go back and down to the bottom, they use more strokes. Flipper strokes are more frequent. And they have lungs, and therefore they need to breathe by floating up to the surface, and then they keep the air inside the lung. The underwater environment is quite unique, 10 meters deep and 1 atmosphere increase. And therefore, when they go deeper and deeper, maybe every 10 meters, the pressure is increased, so their lung gets smaller in volume. It means that the buoyancy gets lower. By taking advantage of this mechanism, when they go up to the float, a positive buoyancy is used, so they don't have to use the flippers at all. This is where they stay still. But when they go down to the bottom, they needed to use a lot of flipper strokes because the buoyancy is still working on them. But the deeper they go, the less buoyancy. Therefore, the frequency reduces, so they don't have to use such frequent strokes, but they can save energy quite successfully and effectively by doing so. When we observe the sea turtles underwater, we could identify that particular phenomenon. Because they are underwater living creatures, and even if we use scuba diving, and 1 hour would be maximum. And of course, if we stay underwater, the nighttime is rather risky and dangerous. So therefore, biologging is very useful. And biologging has a long history, even from the early burgeoning period of this sea turtle study. They live in the shallow water, and also they have a large body. Thanks to that, such a conventional and olden times, data logging device could be mounted successfully without jeopardizing the activities. So this shows the earlier device. When they come to the breeding ground, those female adults come up on the ground, and they breed several times. So 2 weeks afterwards, they come back again to the same beach. Data loggers was mounted, and then even we wait 2 weeks, she comes back to return the biologging device. Therefore, from the very, very early stage of biologging technology, sea turtles were very, very important animals on which it was mounted. In 1991, this one was taken, and Dr. Sakamoto in the division, the School of Agricultural Studies and was using that. But this was fairly large. Therefore, I was wondering if there might be some feeling caused by that. Today, we have the benefit of the advanced technology, especially electronics. Therefore, it is getting smaller and smaller. Miniature size is possible. This is an acceleration type device. It is just as long as the small finger, little finger of humans. Not only the large animals like dolphins and whales and also sea turtles, but smaller ones and also seabirds can be the targets for the data logging and approach. Then we can reveal and elucidate what has been unknown today. By miniaturizing that, there is another advantage. Conventionally, it was mounted on the back of those living creatures. Then the whole body movement and also the depths of the water where the penguins were staying and were identified. But when it gets miniaturized, it can be mounted on specific sides of the bodies. Therefore, we can actually examine the part movement and also the degree of movement. And by mounting that on the smaller creatures and animal science and the scope is being enlarged, and we can learn more and more about their living style and life. This is a green sea turtle. Now, green sea turtle is eating the algae and also seagrass, and this eating and feeding habit is very important. When we are trying to reveal their ecology, we need to identify how they are feeding themselves. That is a very important part of the study. Conventionally, larger data logger was mounted on the back, but that was not good enough to identify when and how that feeding movement was exercised by them. But now this is much smaller, so when they are eating the seagrass and algae, we can understand that then the neck and head is extended quite significantly because of the smaller size of device, and we can even mount it on the head. Then we can keep the record of their feeding activities. So this is what I have done. You can see this acceleration data logger device mounted on the head. By doing so, I could identify the movement backward and forward, and also the movement upward and downward when they try to eat something. I wanted to record the movement of the head itself and when they were feeding themselves. Then the acceleration waveforms can be recorded in the logger that represent their behaviors and feeding behaviors. This is an acceleration data logger on the head, which was very useful for the recording of the feeding activities and the behaviors. You can see detection rate as well as false detection rate. The top one is how accurately we could record the feeding maneuvers and also behaviors. 99.6 is quite high. False detection rate is another one. Although it was identified as a feeding behavior, it was not really the feeding. So that ratio was 24.8%. How should we interpret it? And sometimes they failed to get something in their mouth, and maybe they had a mistaken recognition of the food, and they just put a bit in the rocks and something which was not edible. So that is identified as a false detection. By having this technique, we could have a very accurate and precise information about their feeding activities and at least another effort for feeding themselves. The head movement and the behavior are of my particular interest, and I came up with a new idea. This was the same picture you have seen, and there is something which is inspiring. Please find it out, and please focus your attention on the movement of the sea turtle's head. Have you got some inspiring idea? So it is now on the surface, and it was for breathing, and then after breathing and filling the lung, it comes back and down to the bottom. Did you find something by looking at the head? I will show you another image, animated image. Professor Sato showed the video logger mounted on the sea turtle's back and also a carapace, and from the carapace there was a video taped, and for the movement of the head, breathing was completed. Please look at it again. From this angle, the head of the sea turtle is not visualized, but when actually the sea turtle breathes and the head is extended, therefore you can see that when the breathing is completed, the head comes back to the original position. What does it mean? At the time of breathing, in order to assure the airway to be open, they move the head upward, otherwise they cannot have a successful breathing. This head movement and upward angle actually represent the breathing activities of sea turtles. That was my idea, and I actually did it. And then the detection ratio was 100%, false at 2.4%. It is accurate and precise. And conventionally, I was using the water chamber testing, but I was interested in the natural environment where they were actually living and eating and also breathing. I did not show so much about the experiment, and this is actually the beginning to the end of the experiment. You can see the acceleration data logger mounted on the head and also on the carapace, and it was released into the seawater. From the bottom of the water, I took this film. I wanted to chase and after this sea turtle, but I could not do that. And maybe many people think that the sea turtles are slow, but they are not slow. Once they are underwater, as mentioned by Professor Sato, data logger is released after a certain time. So it is floated on the surface of water, which has got the radio transmitter. And therefore, by using the Yagi aerial or antenna and also receiver, we could actually identify the location of the data logger. So we are now moving ahead and to the data logger. This is actually my familiar place, and it is near Ishigaki-jima Island of Okinawa. And this is between Ishigaki and Iriomote Islands. And I was actually recovering this data logger. So this experiment is totally dependent on the successful recovery of data logger, which is sometimes psychologically pressurizing. But that actually I was catching it, but I missed to take the picture because I was so keen on getting and recovering that device back. The most important picture was rather missing. You can see the dive depth and head movement and also carapace movement. This shows the feeding, so you can see when it was actually engaged in the feeding behaviors. This is the time. These are the times when the feeding and movement was conducted. It was only concentrated on the shallow water, about 2 meters under the surface of water, and we did filtering processing, and you can actually identify clearly that these were the times when the feeding was conducted, 0 time 100 to 2300. In the blue sea turtle, around 7 o'clock in the morning and also noon and also 6 o'clock in the evening, 3 times they eat. So the morning breakfast and also lunch and also evening, which is very similar to humans. That was exciting. Where were they when they were eating? dive and the depth and is represented, and also the ratio on the y-axis. And as you see, that when they were eating, it was only 1 meter, 2 meters, or 3 meters. Therefore, they were in the shallow water. They are herbivorous animals, so their main feeds are the algae and seagrass. In the case of a mammal and the sea algae, they just grow in the shallow water. Sea turtles often stay in the deep water, so in order to get their food, they come up to the surface and the shallow water. This is a breathing pattern. This is the swimming pattern, and this is a resting pattern. So after moving for a while, they have rest. You can see the time elapsed and also the dive depth, as well as the head angle for the breathing activity, and also body movement or the carapace movement. On the surface of water of almost 0 meter deep, and you can see the upward movement of the head. Each peak represent the breathing. When they were staying on the surface of water once, and they have one breathing. But in the case of rapid diving, they conducted 6 times breathing. So when they were active, they had a certain breathing pattern, but when they were resting, there was another different type of breathing. But then we don't know why there are such different breathing patterns, active and also non-active or resting. Maybe the oxygen consumption might be different in sea turtles. That is one hypothesis or one conjecture. This is a summary. From a different angle of thought, and I would like to explain what I have observed. The animated pictures were used in my presentation as well. By looking at those videotape and images, and we can identify something new. For example, the head angle and movement was probably related to the breathing activities, and biologging plus and a moving image and data is very useful. And scuba diving was mainly used because sea turtles live in shallow water. But when it comes to the out water, out sea animals, scuba diving is not sufficient. We need to use another technology such as a camera, a logger device, and also the video logger device. So while staying at the same environment and as their living environment, and we can find something new hypothesis, and maybe we can identify something new. And if we attach the device at the new sites of their body, maybe new monitoring models can be established. These and all these developments will be surely lead to the amazing discovery of those living creatures. This is my last part of my presentation. Video logger has been mounted to sea turtles, and actually I am very keen on developing some video logger for sea turtles. Dr. Asato was manufactured by National Geographic, not Japanese company. I am keen on developing a Japanese-made video logger. I am in the process of development at the moment. This is a water chamber and a water tank, and those the most male and females of the loggerhead is moving, and actually that the male wasn't turned on, and the male is almost attacking the female because he wanted to have mating activities inside the sea tank. This is actually the bottom of the female loggerhead, and who did not like this male at all. So the male could not have that an opportunity at all. So by using the video logger, those mating activities which were not so clearly identified can be perhaps captured, which is my hope. Thank you.